So look at here children. So now here is, if you can see, it just assume that it is a kind of a lever. It's like a straight bar, you think. Fulcrum. Here is a effort. Here is a load. So children, now this is edge where it is touching this head of this hammer. Here is a fulcrum. Hello dear students, in today's class we will be discussing the types of lever. In a previous class of machines chapter, individually we discussed unit A and unit B. Actually there the topic lever, it was not uploaded actually. So that topic today we are going to upload. So in the previous classes we covered the terms related to the machine and the pulleys. There we discussed single fixed pulley, single movable pulley, block and tackle system, and even one short video on machines also uploaded in our channel only. So links will be given in the description. Just kindly go through those videos so that you get a good command on the concepts. So as I told you that in a today's class we will be discussing purely about the levers. Children, first of all, let us try to understand what is a lever, children. Yes, so lever, it can be, it's a rigid body actually. It might be in the form of, it's a straight bar or bent bar, and which is able to rotate about a pivot point, so called fulcrum. Let me show you. For suppose, let us take this. Okay, na? So here is a rigid bar. Here is a rigid one only, a straight bar, which is able to rotate this pivot point, so called fulcrum. So this kind of arrangement only we can call it as a what? Lever. So children, levers are simple machines. Levers are what actually? Simple machines. Now first we'll try to understand on which principle does the lever work. Then what are the types of levers? There we have a class 1 lever, class 2 lever, class 3 lever. So we will discuss individually with the demo. Means I'll try to just we'll try to have a even demonstration. That is what I'll try to show you each and every lever which we will be using in our day-to-day life. Is it clear? Fine children. Now children, first we'll try to discuss and let us try to let us try to see how can we calculate the mechanical advantage of the what we can say levers, children. So first of all, look at here. So let us take, again I'm telling you, we'll discuss the types of lever later. First let us have idea about the principle of lever and its mechanical advantage. So children, here a kind of lever is taken here. Here, as I told you that here is the pivot point, okay, about which this rigid body will try to rotate, so called fulcrum, and either of side just effort and a load are there. And here two terms are very, very important. What is that? Effort arm and a load arm. What is effort arm, children? The distance between effort, the point where the effort is acting to the fulcrum, is called effort arm. What is the load arm? The distance between fulcrum to the point where we are putting the load. So effort arm, load arm. Now children, on which principle does it work actually? So lever works on principle of moments. Yes, this principle of moments we learnt in a chapter 1, so called force. So now what we are trying to do, let us recall here. According to principle of moments in equilibrium, the anti-clockwise moments are equal to the clockwise moments. Now let us try to apply this principle of moments about this fulcrum F. So if you want to apply, principle of moments, first we need to identify the forces and even we need to identify the perpendicular distances. Children, here, so according to this here, either of one, effort is a force only, load is a force only. So either of one can be F1, either of can be F2. So let us say this is, let me check, here is ink is leaking. Okay, fine children, yeah. So here this can be F1 and effort arm can be R1 and the load we can take it as a F2. So that load arm is going to be a R2. Let us apply this here. So according to this, E into effort arm is equal to load into load arm, children. Now try to bring this load arm this side so that effort arm can be taken right side. So it can be written as effort arm by load arm is equal to load by effort. Children, already we knew that load by effort is called mechanical advantage. So finally we got here mechanical advantage is equal to effort arm by load arm. mechanical advantage is equal to effort arm by load arm. So this is a formula which we will be using to calculate the mechanical advantage of a given given lever. And here one more importance is there for this formula, children. So based on this only we can decide whether particular given lever acts like a force multiplier or a speed multiplier, or it is used to change the direction of effort applied. So here based on this formula we have three cases. Let us see that here. Case 1, children, here. For suppose if effort arm is greater than the load arm, that is what here, if a numerator is greater than the denominator, obviously what will happen here, mechanical advantage can be greater than 1. For any lever, if a mechanical advantage is greater than 1, that particular machine acts like a force multiplier. Children, that particular machine acts like a force multiplier. Okay. Case 2 here. If effort arm is less than load arm, then what happens here? That is, if a numerator is less than the denominator, then here mechanical advantage is less than 1. So lever with a mechanical advantage less than 1 acts like a speed multiplier, speed multipliers. And here it is also possible that effort arm is equal to the load arm. Children, what happens if a effort arm is equal to the load arm? Then here mechanical advantage is equal to 1. Children, lever with a mechanical advantage is 1, neither acts like a force multiplier nor acts like a speed multiplier. Then what is the use? Yes, so that particular lever with a mechanical advantage is equal to 1, it is used to change the direction of effort applied, direction of effort applied. Okay, children, so this is very important in order to understand about the levers and types of levers and how that particular levers can be used. Okay, children, just you copy this, then we will discuss the types of levers. Okay, see, okay, before going to erase this, actually let me tell you, children, here levers are classified, but here one important thing we should understand. So whenever we are doing a classification, irrespective of subject, irrespective of concept, children, so we should only concentrate only one point. What is that here? On what base we are going to classify. So if you can understand on what base we are classifying the things, then it will become very easy to us to understand the concept and apply also in our day-to-day life. So especially come to the levers, children. Levers are classified based on the relative positions of effort, load, fulcrum. So based on the relative positions of fulcrum, load, effort, children, levers are classified into three categories. Class 1 levers, children. In a class 1 levers, fulcrum is in middle, effort and the load are acting either of sides. So for class 1 levers, fulcrum must be in middle. Whereas for class 2 levers, load will be acting in middle such a way that either of side, fulcrum and effort will be there. Whereas a class 3 levers, effort will be acting in between and fulcrum and the load are acting on either of sides. So let us repeat here. Class 1 levers, fulcrum is in middle means in between. Class 2 levers, load is in between. Class 3 levers, effort is in between. So these are the three types of levers. So just copy this. Now we'll discuss individually, in detail we'll discuss, and for each and every class lever, children, we are going to see the examples, live examples which we'll be using in a day-to-day life. Okay, just copy this. See, that's fine, children. So now first let us see class 1 levers. Children, let us recall, children. In a class 1 levers, how the relative positions of fulcrum, load, effort. Children, just remember that for class 1 levers, always fulcrum must be in between, whereas load and effort are either of side. Load and effort are either of sides. Children, here under class 1 lever, actually, so we have three cases actually. So why we have three cases? Yes, you will understand at the end of the discussion. So children, here, so you can see just three figures. Here fulcrum is in middle, load and effort are either of side. Here also fulcrum is in between, load and effort are either of side, and here also fulcrum is in middle, in between, so that load and effort are either of sides. So these three are class 1 levers only. Now if you can notice here children, in this class 1 lever children, yes, fulcrum is in between, such a way that the effort arm is equal to load arm. Effort arm is equal to load arm. So whenever effort arm is equal to load arm children, mechanical advantage is equal to 1. If a mechanical advantage is equal to 1, that particular lever is used to change the direction of effort applied. The best example children, the best example for this class 1 lever with the case 1 is actually seesaw. Okay, just I'll try to show you the model, it may not be exactly. So look at here children. So now here is, if you can see, it just assume that it is a kind of a lever, it's like a straight bar you think. So here it is a pivoted in between, right, in middle. So either this side if you can put a load, here load you can put, then effort you need to apply here. If a load is here, then effort you have to put this side. So this is what actually class 1 lever. If you can see here, so almost I tried to adjust such a that this left side length is equal to the right side length. So this is the best example for case 1 of the class 1 lever. Case 1 of class 1 lever where mechanical advantage is equal to 1. In which case mechanical advantage is equal to 1 children? Where effort arm is equal to the load arm. Is it clear? Fine children. Now here case 2 children, and as we know that fulcrum is in between, right? But the thing is that fulcrum position can be adjusted. It can be moved either towards left or towards effort also. So by changing the fulcrum position children, we can change the mechanical advantage of the class 1 lever. Is it clear? In exam they'll ask you a question, how can we increase the mechanical advantage? Yes, by increasing, see already we know that here mechanical advantage is equal to effort arm by load arm. So by increasing the effort arm or by decreasing the load arm, we can increase the mechanical advantage. So now if you can see in this situation children, here fulcrum is adjusted such a way that it's very near to the load, which means what? If you can see near to the load means effort arm is increased. So effort arm is greater than load arm. So whenever effort arm is greater than load arm children, mechanical advantage will be greater than 1. Then that particular lever acts as a force multiplier. Now what are the best examples? Yes, pliers. Now first we will see a pliers. Okay, let me take out. Almost here we have all. Yes, let me show you. So children, so here is the pliers, try to understand. So we can say cutting plier also. Okay, fine. Now see, try to understand. This is what actually, this is the position of the what? Fulcrum. These are the ends where we are going to apply the effort. So here this is the effort, here is a fulcrum. So this distance will be the effort arm. Now look at, try to understand. So with this we are going to cut like this. Generally electric wires and thin wires we will cut. Try to understand. Now this is going to be a load. This is a load children. So this will be what actually load distance. So let me show you like this. Yes. So children, try to understand. Here is a load, fulcrum, effort. So effort arm is greater than the load arm. Excuse me. Yes. So hope it's a clear children. So plier is the best example for class 1 lever which behaves like a force multiplier. Why it behaves like a plier's force multiplier children? Because here effort arm is greater than load arm. Try to understand. Hope you are able to see this. Yes. So this is a fulcrum. Here is a effort. Here is a load. So fulcrum is in middle. So this is effort arm. Here is a load arm. Is it clear? Fine. Right. Now here second one is spoon used to open the lid. Yes. Here we have that arrangement setup also. Let us see here. Okay, children. Here is a spoon and here is, let us take this tin, and here is this lid is there, you know. So generally whenever we are trying to open with our finger or hand, it might be difficulty sometimes actually. Sometimes, I'm not saying always. So for that only we are going to use a spoon. But here you may get one doubt, sir, how this spoon is a class 2 lever? Look at here. So it is placed here children. Try to understand. Now this is a point where I am applying the effort. Oh, excuse me. Yeah. So this is okay, no problem. So this is a point where we are applying the effort here. But if you can see, this lid is going to be the load. Lid is going to be the load. But when I am trying to do like this, So if you can see with my here, so this position children, these try to understand. So now here is the effort, here is a load, okay, and this is what actually fulcrum, where it is touching this edge, where this spoon is touching this edge is going to act like a fulcrum. Now what will happen? Yes, with this we can open the lid easily, right? We can open the lid easily. Try to understand. Like this we are lifting, right? Now you can see, yes, now you can feel. So here lid is a load. So now the spoon, the point where the spoon is touching the edge of the tin is acting like a fulcrum, and look at here, the edge where I am applying the force is a effort actually. So effort arm is greater than the load arm. Hope it is clear. Yes, yes. It is also class 1 lever with, which behaves like a force multiplier. Yes. Now let us take a third one, claw hammer. Yes, yes, we have that arrangement setup also. Yes, children, today we are with a complete preparation, right? Okay, look at here children. Now here is a claw hammer, okay, which is used to take out the nails which is easily. Now look at, try to understand here. So this how we'll try to look. Okay, now let me just try to okay, now look at here, I'm trying to show you children. Now this is edge where it is touching this head of this hammer, here is a fulcrum. Now this nail is a load, this is a point where I'm applying the force is the effort. So this to here it is a effort arm, this is a effort arm. So load arm will be this much only, right? So effort arm is greater than load arm. Then what will happen? With the help of this, easily we can take out the nail. Okay, now we can take out the nail. Try to understand children, I am trying to show you. Is it clear? Okay, now yes, 3, 2, 1. Go to the nail. Thus, okay, now fine. This is the class 1 lever which acts like a force multiplier. So these are the best examples for class 1 lever behaves like a force multiplier. Yes, children. Now if you come to the case 3, so where position of the fulcrum is moved towards the effort, right? Adjust such that effort arm is less than load arm children. So when effort arm is less than load arm, mechanical advantage will be less than 1, then it acts like a speed multiplier. Then what is the best example? Yes, best example, yes children, here is a scissors. Scissors with a long blade. Scissors with a long blade are the best example for what children? What here? Class 1 lever which acts like a speed multiplier. Now let us see, for suppose let us say, just we are not going to cut, just I am trying to show you. Okay, let us say here is a cloth. So this is where I am putting actually. Okay, try to understand. Now this is a position, yes, let me show you like this. Yes, this is a point where I am putting the effort. Okay, now is a fulcrum. So look at here, this is a effort arm children, effort arm. Point where I am applying the effort is a fulcrum, this is a effort arm, and here is a load. If you can see here, this is a fulcrum position, here is a load. So load arm is, look at here, load arm is greater than effort arm, load arm is greater than effort arm, then mechanical advantage will be less than 1, it behaves like a speed multiplier. Okay children, these are the class 1 levers children. Whatever we have seen till now all comes under class 1 lever only, but there also again we have a classification whether class 1 lever is acting like a speed multiplier or we are using like a force multiplier or it is used to change the direction of effort applied. And you should remember one important point, no lever can be used as a force multiplier or a speed multiplier at the same time, either force multiplier or speed multiplier. Is it clear? Just copy this. Now we discuss class 2 lever, class 3 lever. Fine children. Now let us see the class 2 levers children. So in a class 2 levers, let us try to understand, try to notice the relative positions of fulcrum, load, effort children. So for class 2 levers, load is in middle. So either of side fulcrum and effort will be there. So this load position can be adjusted, but load arm can never be greater than effort arm, which means for a class 2 levers, effort arm is always greater than, see this one you can put here, but effort arm is always greater than load arm, so that what will happen, mechanical advantage is greater than 1 children. So class 2 levers acts like a force multipliers, that is what actually Bahubalis. So class 2 levers are always Bahubalis. So in exam don't write like a Bahubalis. So what I mean to say is that yes, always acts like a force multipliers. In exam they may ask you a question, which class of levers always acts like a force multipliers? Give a reason. Yes, class 2 levers always acts like a force multipliers because effort arm is always greater than the load arm. Effort arm is always greater than the load arm. Is it clear? Yes. Best example, nutcracker. Yes. So here we have a nutcracker, but we don't have a nut. Nutcracker is there. Okay, children. So look at it. Try to understand. Here is a nutcracker. So this is what actually fulcrum. Right. Here is a fulcrum. This is the position where we are going to apply the effort. So for a nut, what we can see, nut. We don't have any nut, but something let us take as a load. Okay, just I am taking this as a load actually. Please don't think otherwise. Okay, don't mind. Okay, look at it. So like this actually. So try to understand it. So try to understand. So I think I have to show this side so that it will be very easy to you. Yes. Now this is a fulcrum, children. Hope it is clear. Here is a fulcrum. Here is a load. So this is a point effort. So if you can see, this is effort arm. Here is a load arm. So effort arm is greater than load arm. That's what nutcracker comes under class 2 lever. Okay, now fine. Okay, the second one here is lemon crusher. Yes, we have a lemon crusher. Lemon crusher. Yes, we have a lemon too. Okay. Okay, now try to understand, children. Okay, so now here is a lemon crusher, also best example for class 2 lever. Why it is a class 2 lever? Yes, so this is a fulcrum, children. Try to understand. So here is a fulcrum. Right on, here is a fulcrum. Now this lemon is a load. This end where we are applying the effort. So try to look at here. Yes, this is one actually. So if we can crush like this, right? Yes. So here is fulcrum, load, effort. What is effort term? The distance between fulcrum to the effort, try to understand, children. So here in this case also, sorry, I don't know whether I have told you or not. So from this point to this point is the effort arm, try to understand. So here also, from here to here is effort arm, and from here to here is load arm. So effort arm is greater than load arm. That's what it is, a class lever and behaving like a what can we say, force multiplier. Is it clear? Fine, children. And next one is bottle opener. Yes, actually we have two types of bottle openers, but here is this bottle opener. So but we don't have bottle, I forgot. Okay, so let me try to, can we just wait. Okay, here is, we don't have bottle to open, but okay, let me show you. Here is a bottle opener, children. Try to understand when we will try to open this, either thumbs up or a Pepsi or anything, some yes. So the moment where we are applying the effort, children, this is the point where I am applying the effort. So now this is going to act like a, what, children? Here load will come actually, and this position, try to understand, and here this is a acts like a fulcrum, try to understand. So here is a effort I am applying, and this is a load actually, and this end, this edge acts like a what, children? Fulcrum. Then what will happen? This is a effort arm and this is the load arm. So if you have a opener, just in presence of your parents, you also can try to have better understanding. Clear? Okay, so these are the class 2 levers. So class 2 levers are bahubalis. I mean what? Force multipliers. Now come to the class 3 levers. So for a class 1 lever, fulcrum is in middle. For a class 2 levers, load is in middle. Now for a class 3 levers, effort is in middle, right? Yes, for a class 3 levers, effort is in middle and fulcrum and load are either of sides. Such a with that, effort arm is less than that of the load arm. As the effort arm is less than the load arm, mechanical advantage of a class 3 levers is always less than 1. Hence, class 3 levers always acts as a speed multipliers. Means what? Athletes. So class 2 levers are bahubalis. Class 2 3 levers are athletes. You may get one doubt, sir. What about class 1 levers? Class 1 levers are all rounders. They act like a force multiplier. They act like a speed multiplier. They are even used to change the direction of effort applied. But class 2 levers are always force multipliers. Class 3 levers are always speed multiplier. Best example, tongs. Yes, tongs. Yeah, here we have tongs. I mean to hold even fire tongs. For chapati purpose also we can use. Okay now, so here look at here. Yes, I'm holding this. Try to understand. Okay now, what is that here is? Yeah, this side. Look at here, children. Just I'm holding this. Try to understand. Now here is, this is a load, children. Okay now. Now this point is a fulcrum. Now where we'll be holding? Yes, we'll be holding this. So these are effort. Try to understand, children. So here is load, here is effort, and this is a fulcrum. So distance between fulcrum and load is a load arm. The distance between fulcrum and effort is effort arm. So here effort arm is less than of the load arm. Hence mechanical advantage is less than 1. So this tongs, I mean sugar tongs, fire tongs comes under what, children? Yes, class 3 levers behaving like a what we can say, speed multipliers. Yeah, here is boat race. Yeah, children, if you can see now boat race, children, so where in some areas there will be some festivals will be there. I don't know that festival so called. If you have idea about that, please excuse me and just try to mention in a comment box. I'll just try to go through it. Okay, so in that boat racing, children, for example, so here we need something like yeah. So here let us say that it's that's handy. Try to understand. So what they'll try to do, just so yes, try to understand. So like this they'll be holding. Okay, now so try to understand. They'll be try to holding. So here they'll hold. So like this they'll be doing very fast. Right? Try to understand. So here the water will be the right. So water is a load, and where they are applying the effort, children, in middle, and this hand where it is, see where it is able to turn, where able to run, it's a fulcrum. So now look at, yes, so I can you feel like, so boat racing like this, so you can, okay now, so this also, which means what here in a boat race, so rowing a boat with a short handle comes under class 3 levers. Is it clear, children? Fine. And here one more important thing is that, so we also can identify these 3 class levers in our human body. So first come to the class 1 lever, children. Class 1 lever fulcrum should be military. Yes. So try to understand try to notice my head, children. So yes, we can noting the head. You also can try, but be careful. Okay, be careful. Slowly you can see. So now this neck point, this will be the fulcrum. So either my chin or back, this head. Either this is the load, this is the effort, or this is the load, this is the effort. Look at here. Okay, now. So here is a fulcrum, class 1 lever. Now class 2 levers, children, class 2 levers, just try to stand on your toes. Oh, now it may not be captured in a camera. Yeah, I'll try to show to some other person. Okay, but you try. So whenever you just try to lift your entire body and toes, what will happen? Your effort, where that muscles which will be you're trying to pull upward direction is effort, but whereas your weight, so-called load, will act in between. But where you're trying to stand on your toes, this toes will be the toes will be the fulcrum. Okay, now fine. And here I'll give you one more example for a class 1 levers in our human body, but I need a small weight. Yes, look at here. So I think some of you may go to gyms, or in futures you may go. So when you are doing like this with the dumbbell, children, so when we are doing like this, try to understand. And this is a fulcrum. Here is the load, and effort will be here. Just try to hold your muscle here. It will become very tight here. So it's the class 1 lever, like it's a lifting like this. Just lifting a weight here, I can say that. So here is a fulcrum, here is a load, and here is a effort. Okay, fine. And for example, okay, same thing if I am holding like this continuously, like this I am holding the weight. Yes, so when you hold like this in children continuously, here you will get what actual pain, which means what, effort will act here, load, effort, fulcrum, effort, load comes under class 3 lever. So effort, load, and here is what actually fulcrum. Okay, children, fine. So these are the types of lever. Hope, children, I think I'm just expecting that yes, this lecture is very useful to you all. Just go through it. And one more thing, children, whenever you are going through our video, in between you can pause and make a notes. And every time I'll tell you, the very important thing is that yes, ultimately you must go through a textbook. That is the basic and the best material. So go through the textbook, note down each and every point, try to make your own notes. And one more thing, if possible, try to attempt the questions which are given at the back of the textbook. And if you have any doubts, yes, come back to our channel and you comment your answer. Definitely 101% I will respond to your doubts and try to give you the answer also. I'll try to give you the clarity. Okay, children, as I told you that previously we uploaded the 3 parts of a machine chapter. Okay, already based on the pulleys and block and tackle and terms related. Yes, all links will be given in the description. Kindly go through those videos to get a good command. In the next lecture, children, immediately we will be uploading the numerical. So here we have a unit A numericals, unit B numericals. First next we upload the numericals based on the levers. Then we will upload the numericals based on the pulleys and the block and tackle system. Okay children, thank you so much. All the very best.